Okay, so here we go. Covalent bonding. And so now we're thinking about combining things that are non-metals, or sometimes I just say not metals. So we're not going to have any metals here. And so things like carbon dioxide, like water. I mean, there's no metals there. And so these are different because they are interested in sharing electrons, and they're not interested in taking them from each other. And so we're going to start to look at things like Lewis structures. And so a Lewis structure is just when you are taking a chemical and you are putting dots around it to represent the electrons. And so the chlorine here gets 7 dots. And then it's like, well, how do I know how many dots to give something? Okay, so that's pretty easy. So let's see let's go to my periodic table here at the end real quick, because I want to be able to write on this one. And you should probably write this on your periodic table if you don't have it, because that's going to be something that can be pretty darn useful. And so get out your periodic table and let's talk about this concept of the valence electrons. So we know valence is on the outside, but we need to be able to look at the periodic table and figure it out. So the way the valence electrons work, and I'm going to write valence electrons, and so we're just going to abbreviate that with a VE. So what happens is based upon the column, and so we're only going to do the bigger columns, and so we're going to go here, these, and that one. Okay, we're not going to mess with the middle because that is varied, and so we're just going to go in these areas. So column 1A gets 1 valence electron. Column 2A gets 2. And you can kind of start to see a pattern, right? So we're going to go 3, 4, 5, 6, 7, and then 8 valence electrons. And so now, when we're looking at this, the exception that we have to remember is that we need to remember that helium, which is right here, helium is the exception. So helium is only going to have 2 valence electrons. And so you can see, why do we call it the octet rule? Why are we starting to like why is that important? Well, right there, there's 8. These are the noble gases. And so octet, if you take away helium, octet equals the noble gases. And so that is the goal of every one of these elements. And so the reason they're trying to get to 8, trying to get their outside structure full of electrons, is they're trying to get to that number 8. So let's go back to where we were in the notes. All right. So we're back, and now we kind of at least know why that chlorine has those 7 dots, because that chlorine is in column 7, so it gets 7 dots. So if you're just drawing an element out, which you don't do a lot, like if you're just drawing an element, you just put the dots in pairs. And so like oxygen, you can like go 2, 4. You could do like 6. So these single ones, like if you put them in, you want to make sure that there's electrons on each side of the box. I'll talk about the box a lot, but when you're drawing them by themselves, like I wouldn't want to do it like this and have nothing there. I'd rather split these out. Not that it's a big deal, you just need 6 dots. Now these are technically bonding sites, and that's kind of where we're going with some of this. Okay, so let's look at some of this. It says the Lewis structure is going to indicate the proportions in which atoms combine. So that's just if you've got water, that's just like saying, okay, hey, in water you get 2 H's and 1 O, right? Like that's not a big deal. It also shows atoms obeying the octet rule if they do obey the octet rule. And so the funny thing here is we tell you about how every chemical wants to get to 8, yada, yada, yada. But then later on, we're going to tell you that, well, sometimes it's okay for you to have 10 electrons, or sometimes it's okay to have 12 electrons, and those are obviously not 8. So 8, most of the time, and this is one of those situations that, we just, have all these exceptions in chemistry, and that's what's always hard is these little ticky-tack factoids. So, all right. Now, the nice thing about this is it is a skill. We are not memorizing. It's a skill that we're going to learn. Once you have the skill, if you combine it with some memorization, then you're going to get all these right, and that's awesome. Okay, what's a bonding pair? The bonding pair are going to be electrons that are in a bond. And so, like if I draw carbon dioxide, which has a couple of double bonds, and then some electrons over here, the bonding pair are the electrons that are in bonds. And so like right here, those are bonding pairs. Okay, so your bonding pairs are electrons that are in a bond or they're shared in a bond. And so we should write down a little definition that a bonding pair are shared electrons and so the way you're going to see that is like you would see, let me use carbon, you would see like this or this or this. Those are all bonding electrons. And so the bonding pair is specifically one of them, right? So like this is a bonding pair, and this is then 2 bonding pairs, and this is 3 bonding pairs. So a line is representing, like this line here, it's like carbon has an electron that's sharing with this carbon. And so instead of drawing the 2 dots, we draw it as a line. Now, in some of these pictures that I have here, they're doing X's and dots, which is okay if you want to know exactly where the electron came from. So if you look here, in this particular example, the X's are all the electrons that came from oxygen, and then the dots are from the hydrogen. So see, this hydrogen has 1 electron, this hydrogen has 1 electron, and this hydrogen has 0. And so it's like showing where the electrons came from in the bonding process. And so non-bonding pairs are also called lone pairs, and those are just dots that are not being shared. And so like here's a lone pair, here's a lone pair, here's a lone pair. So these are electrons that are not shared. And so we draw them as dots. And so that's how you're going to see them. These are electrons that are not shared. And so an example of that is like if you're seeing dots, like I've got these dots right here, this is what we're talking about. These are alone and those are not being shared. So pretty easy, just the dots that are not shared, because we're not going to use this same X's and dots. We're just going to do lines. And so like in these examples here, these are shared, these are lone because they're by themselves. These are actually all shared. So I don't usually use this. I don't have you draw them like that, so it'll be a little easier. Okay, this is something that comes up on every once in a while. I don't want you to spend a lot of time with it, but a coordinate bond is when you have a bond, but one of the elements is kind of a slacker, and it can't provide an electron to share. So it's like, hey, I don't have anything to share. So the other one feels sorry for it and gives it 2 electrons, and they still share. It's just that one of the chemicals is providing both of the electrons. So if you look here, and I don't want you to worry about this because I don't put it on my test, but it could come up on the IB exam, and it's also useful in later units. If I look right here, and I'll use my highlighter, right here, right there, those highlighter's not really working. Nitrogen is providing both of these, and see this hydrogen, it has 0 electrons. It doesn't have anything. It's like looking for a handout. It needs a little bit of help, and so it doesn't provide anything. The nitrogen did all of the work there. It's like, okay, I've got 2. I'll share with you. If you look here, see, this hydrogen provided 1, and this hydrogen did, and this hydrogen did. So these guys all provided an electron. It's just this one didn't. And so we call that a coordinate bond. A coordinate bond is where one element is doing all of the providing of electrons. This is not on my test. It is possibly on the IB exam, and it is a topic that is useful later on, but we don't need to spend a lot of time with it. Okay, multiple bonds. You have double bonds where you have 2 shared pairs like up here, and you have triple bonds which have 3 shared pairs right up here. And very, very, very important is there is no quadruple bond, right? So there is no quadruple bond like that. So if you ever have a bond with 4 lines, it is wrong. Okay, so if you are drawing something out and you are like, and you're like doing this, right? And you're like going along and you're like 1, 2, 3, 4. That's always going to be wrong. So if you find yourself doing that, that's bad news. Like, you're going to get a big fat F and you're going to be super sad. So make sure that you don't do that. So next is I can actually show you how to build these things on your own. So we're going to go through a little bit of comparing the 2 types, right? So we're going to compare ionic to covalent, but then we're going to show you how to draw these. So we'll kind of finish